Hello everyone, and welcome to this tutorial. In this video, I'm going to walk you through the process of creating a simple inverting amplifier using an operational amplifier, or op-amp. Whether you're new to schematic design or just looking to improve your circuit building skills, this step-by-step guide will help you understand how all the components fit together. Before we begin, you'll notice that I have a circuit diagram displayed on the right-hand side. This is the completed inverting amplifier circuit that we're aiming to build. On the left-hand side is the workspace where we'll create the circuit from scratch. Keeping the finished circuit visible allows you to compare your progress as we go and makes it easier to understand how the schematic develops piece by piece. With that said, let's get started. The first component we need is the operational amplifier itself. To add this to the schematic, navigate to the Parts tab in your software. Locate the op-amp symbol, click on it, and then drag it into your workspace. Once you've positioned it where you'd like it, release the mouse button to place it on the schematic. Now that the op-amp is in place, we need to provide it with power. Most op-amp circuits require both positive and negative supply voltages. In this example, we'll use a positive 12-volt supply and a negative 12-volt supply. Begin by adding a plus 12-volt source and connecting it to the positive power pin of the op-amp. Then add a 12-volt source and connect it to the negative power pin. These supply voltages will enable the op-amp to operate correctly and amplify the incoming signal. Next, let's add the resistors that determine the amplifier's gain. First, place a 10 kΩ resistor between the input signal and the inverting input of the op-amp. This resistor serves as the input resistor and is an important part of setting the circuit's amplification factor. After that, add a 100 kΩ resistor between the output of the op-amp and the same inverting input. This resistor creates the feedback path that gives the circuit its stable operation and establishes the gain of the amplifier. At this stage, the basic amplifier structure is beginning to take shape. The next step is to connect the non-inverting input of the op-amp to ground. Add a ground symbol to the schematic and connect it directly to the positive or non-inverting input terminal. This is a key characteristic of a standard inverting amplifier configuration. Now, let's create the input connection that will allow external signals to be connected to the circuit. Add a connector on the left-hand side of the schematic. Connect one terminal of this connector to the input resistor you added earlier. Then connect the other terminal of the connector to ground. This provides a convenient interface for connecting an input signal source while maintaining a common ground reference. With the input complete, we can move on to the output connection. Add another connector to the schematic for the output. Connect one terminal of this connector directly to the output pin of the op-amp. Then connect the second terminal to ground. This arrangement makes it easy to connect measuring equipment, such as an oscilloscope, or to interface the amplifier with other circuits. We're almost finished. The final task is to create a connector for the power supply connections. Add a power input connector with 3 terminals. Connect the first terminal to the positive 12-volt supply. Connect the second terminal to ground. Finally, connect the third terminal to the negative 12-volt supply. This provides a neat and organized way to connect power to the circuit whenever it is used. And that's it. Our inverting amplifier circuit is now complete. If you compare the schematic we've just created with the finished version shown on the right-hand side of the screen, you'll see that they match perfectly. By building the circuit one component at a time, we've created a fully functional op-amp-based inverting amplifier and gained a better understanding of how each part contributes to the overall design. Finally, I will delete the circuit on the right. I highly recommend taking a few minutes to recreate this circuit yourself. Hands-on practice is one of the best ways to become comfortable with schematic design. The more circuits you build, the faster and more confident you'll become at creating your own designs from scratch. Thanks for watching, and if you found this tutorial helpful, don't forget to check out the other electronics tutorials for more circuit design tips and techniques. I'll see you in the next video.